problem is to evaluate the polynomial given here. We are given with the x value and we have to find the value of the polynomial for that x. In general, what we can do is replace this x with the given value and solve the polynomial. It is called straightforward determination. But the problem with this approach is it takes n into n plus 1 by 2 multiplications and n addition. So it is a computational overhead for the computer when we want to solve it from that. Here we are trying to develop an algorithm which takes less computation to solve the problem. In that way, it is more efficient than this, the direct straightforward determination. So let's see the procedure for that. I have rewritten the equation here. Now I can see from leaving the first term, I can see here x is common in all these terms. So I have taken that x out. Now after that, I have some equation like this. From the second term, I again have an x common. So in the second step, I have taken that x again, and following this approach again and again, I can reduce the above equation to this. So the advantage of this approach is that it takes only n multiplication. So it is far more efficient than the earlier one. Let's see algorithm for this. Here is the algorithm. Read x in n. After that, for n values, read an array of constants, that is for these a values, n. After that, assign p to the last term, last coefficient, and after that, from n to 1 iterations, what we have to do is multiply p with x and then add with the n minus 1th term, the term before the last term, and sum up this and assign to p. In the next iteration, the p will be the last term's result. We will be multiplying it with x again and adding the earlier term from the current one. So following this, we will get a final p value which we are going to print. It is the algorithm. Let's see flowchart. Here is the flowchart. You can see first read. After that, in a loop, read all the values. Again a loop. Again an assignment for last term to p. Then a loop for calculating p, and finally write the p. Thank you. The next step is to divide the polynomial with the term x minus r. So let's see the division procedure first. You can see the division procedure here. We are dividing the polynomial with x minus r, and finally we are getting some quotient. We have reduced the quotient to the term given in the last of the procedure, b n minus 1 x n minus 1 plus b n minus 2 x to the power n minus 2, and so on. As you can see, I have returned the results from the division procedure. It is the final reduced polynomial after division. We can assume b to be an array of output coefficients, and we have obtained these output coefficients by these assignments one by one. So in general, we can get an output array by this equation, where every bn minus I plus 1th element is equal to this term. So let's see the algorithm which uses this procedure to solve the problem. Here is the algorithm. First read x and n. After that, read input coefficients, and then following the assigning the first value to the b array, that is the last term from a array. After that, in a loop, assigning all the b values using this assignment equation. Finally, we have prepared an array with all output coefficients, so we are going to print this with the for loop. Let's see the flow chart for the problem solution. Here is the flow chart. First read x and n. After that, in a loop, read all input values. After that, assign first b value, and in a loop, calculate all the b values, the values in the b array, that is output array, and finally print them out.